take some examples here of these transition metals of our D block elements. Here's an example where we have tin 4 iodide. Remember, this Roman numeral represents the charge on tin. So I know here that it's going to be Sn plus 4. Copper 2, that's going to be copper plus 2. That's what the Roman numeral represents. PbO, lead 2 oxide, the plus 2 and versus a lead plus 4 oxide. So let's look at some of those examples. Here's copper 1 oxide. How am I going to write the formula of this? Well, copper's symbol is Cu. I know it's 1, so it's going to be a plus 1. I'm combining that with an oxide. Oxygen has a -2 charge on it. So crisscross method leads me to a copper 2O. Cu2O, copper oxide. Let's try this one, iron sulfide. This is Fe, and this is going to be a plus 3. And then sulfur, which is a -2 as well. If you don't know that, look on the periodic table. The group number will tell you its typical charge. Crisscross method, the 2 goes down here on the Fe, so it becomes Fe2. The 3 comes down here on the S, so it becomes S3. Balanced charges. Iron 2 with a plus 3 charge is plus 6. 2 times a 3 is going to be a -6. So a -6 and a +6 balance out. You do not have to put the charges in the final compound. If you do write in like the plus 3 here and the -2 because that helps you, that's fine. I won't take off points for it, but you don't have to do that. It's okay leaving it with no charge in the final compound. Let's look here at some of these examples. Cobalt iodide, that's going to be its name, and we need to write that out here. So it's going to be cobalt because that's my metal cation. Now, cobalt, if you're not sure, is cobalt a transition metal and you're not sure, well, take a look here at your periodic table. Let's find cobalt. It's right there. It is a transition metal. It's hard for you to see, but it can be a +2 or a +3 charge. So if I'm coming back to my example here, I know that cobalt can be a +2 or a +3 charge. In this case, cobalt is with an iodine. One iodine is -1. So I know I want my cobalt to be a +2 to balance my iodide's charge. And again, I have to put this +2 in there because it's a transition metal. This is a stock nomenclature. I have to use it to indicate the charge on the metal cation. Let's try Hgi2. Hg. Well, you're not real sure, can't remember what Hg is. Always look at your periodic table, find it right there. It's mercury. Mercury can have a lot of different charges there. So I know that it has all of these different possible charges, +1, +2, +3. If I go back to my example here, I have another iodine. And again, iodine is going to be here in 7, -1 charge. So let's go ahead and look here at our naming. I know iodine is a -1 charge. I need to make it a balanced compound, a neutral compound. So I end up here with mercury. And overall this is -2, so mercury is going to have to end up being a +2. I only have one mercury, so it has to be a +2 to balance my iodide's -2 charge. So go ahead and try the rest of these on your own here. If you end up trying these and you want to check your answers, there you go. There's the rest of the answers. For that, you can pause the video, write them down. And if you want to see all the correct answers on the name to formula, there you go as far as the right answers go. Last thing here, and then we're going to wrap up and finish. Polyatomic ions. Again, you need to know your polyatomics. Our group of covalently bonded elements, but they have a charge. There are some common ones. You have a whole list of them. Don't lose the list. It's on my website if you do. Let's look at how we use the polyatomics in naming ionic compounds. Here's a few examples. Here we have an iron with a PO4, phosphate. You need to know here phosphate has a -3 charge. Since phosphate has a -3 charge, then my one iron has to have a +3. So again, that's where the Roman numeral indicates the charge on the ion. Calcium sulfate. Here you do not have to use a Roman numeral because calcium is in group 2, so they all have a +2 charge. Sulfate overall has a -2, so one calcium and one sulfate balance out neutral compound. You want to look here at silver nitrate. Again, silver, in this case, I know silver is a +1 charge because my nitrate is -1. They have to balance. And potassium carbonate. To name these, all you do is you take your cation and it stays the same. So that's my cation. And your polyatomic here, you just write your polyatomic's name. So let's look at some examples here. Sodium cyanide. You need to know that cyanide is Cn and it has a -1 charge. Again, I always put my polyatomic in parentheses because the charge is indicating of the entire compound. Sodium, group 1A metal, is going to be +1, so it ends up being an Na plus with a Cn -1 charge. That yields me NaCN, balanced compound. Let's try calcium carbonate. Calcium, look on your periodic table, +2 charge. Carbonate, CO3, look on your periodic table, -2 charge. What do we get out of that? CaCO3. Again, put your polyatomics in parentheses. Try this one. Hydrogen, plus charge. Peroxide, you need to know, is O2 with a -2 charge. Uh-oh, charges don't balance. Crossover method, I'm going to get H2 because I take this 2 and I bring it right down there. And this 1 goes right here, so it's H2, O2. +2, -2, overall neutral. I really suggest try these examples as you see them here. Try them out, see what you get. For the rest of these examples, there's your answers if you do work them out. Pause the video, write them down. Let's look here at some compound to name examples. If you're given a compound and you want to get its name, let's go ahead and dive in here. We'll start with this one, start down the list. NH4, I recognize this as a polyatomic and I recognize this as a polyatomic. This is going to be ammonium and NO3 is nitrate. So I just write it in, ammonium nitrate. This is a good example here because I know iron is a transition metal. So that means I'm going to have to check the charge on iron. And then ClO2. I'm not too sure what ClO2 is. Check your reference list here to see if you can figure out what polyatomic it is going to be. And in this example here, ClO2 is chlorite. So I'm going to write in chlorite. And my polyatomic list tells me here that chlorite in this example is a -2 charge. Well, -2, and there's 2 of them, makes it a overall -4 charge. I need iron to be a +4, so I use a Roman numeral, number 4, to represent a +4 charge on iron to balance the charges. The reason there's only 1 iron here, so I know it has to have a +4 to balance the -4 of chlorite. One last example here, potassium and ClO4. Again, you need to know your polyatomics. You need to know. If you don't, check your reference sheet right there, and this is going to be perchlorate. perchlorate has a -1 charge overall. So I'm going to have potassium. I write my metal just as it is. I know potassium's a +1 charge because it's in group 1A. So potassium and then perchlorate as the name of my compound. Again, if you would like to try these examples and you want the answers to the rest of them, you're more than welcome here to try these and get the right answers. There they are. This should wrap it up for us on naming ionic compounds.